Okay, 1.5 day 2. I'm starting off with number 53. And for 53, it says g of x is equal to negative f of x. The transformation here would be a reflection across the x-axis. And the reason is when I see f of x, I think of y. So this is really negative all of the y's. That's number 53. Number 54. For contrast, what if I had the function f of negative x? So when I see this, I see that all of the x's have been replaced with negative x. And so this is a reflection about the y-axis. So if over here, on the first one, if I had the point xy, then on my new one, if all the y's are negative, I would have the point x negative y. For this one, if I had the point xy right here, then on the new one, I would have the point negative x y. That is why it is a reflection about the y-axis. 56. So then if I look at 56, if I have g of x is equal to 6 f of x, when I see that, I see 6 times my old y's because f of x is y. So this is going to be a vertical stretch by a factor of 6, right? That was 56. And then for 57, so that's 56. I'm going to take a second and look at 57. And so for number 57, sorry, I was on the wrong screen. So for number 57, if you have g of x is equal to f of 5x, well, if you had to picture something like this, well then it's going to go through the picture 5 times as fast, so maybe it looks like this. Because we think of t as time, and so we're moving through the picture 5 times as fast. So this would be a horizontal compression by a factor of, and again, when you mess with x, it does the opposite. So this is a compression, and also it's by a factor of 1/5. So for example, if this was the point 1, 1, then if we go by a factor of 1/5, this is going to be the point 1/5, 1. Right? Okay, so that's 57. So then we look at 64. So 64 says I've got the graph of this. And it says my function, if this is my parent function, then I change it and reflect it over the x-axis. So if I'm reflecting over the x-axis, then that means my y's change from positive to negative. So my y's change from positive to negative. So I think it's going to be this is over, it's going to reflect over the x-axis. So all my old y's become negative y. So that's why this is negative square root of x. Horizontally stretched by a factor of 2. So if I horizontally stretch by a factor of 2, then it's going to do the opposite of what I think. And it's actually going to horizontally stretched by a factor of 2. So I want to pull it out. So I want to take this and I want to pull it out this way by a factor of 2. That means I would multiply it by 1/2 on the inside because it's going to take half as long. It's going to go twice. It's going to go half as fast. Again, you can think of t as time. If its time goes to half time, so it's going half as fast, then it will take longer to make that picture, and so it's going to be that. Then it shifted, wait, this is 64, and that's it, right? So that's 64. And so now it went 66, So this would be our original. I don't want to say those are equal. This is your original. When you do the reflection, you would get this. And then when you do the horizontal compression, horizontal stretch, you would get this. So those are all different functions. So that's 64. 66 says, look, I've got this thing. Write a formula that gives the graph. So it wants to write a formula that gives the graph. So if that is it, if I vertically stretch by a factor of 8, vertical stretch means you're going to you're going to mess with the y's. So if I vertically stretch by a factor of 8, my new function is going to be 8 times my old y's, which I think you could just rewrite as 8 over x. And so that's 8 over x. And then what? Shifted to the right 4 units. So that means if I go right 4, then I'm messing with x. So this is going to be x minus 4, because it does the opposite of what I think when we mess with x. So that's right 4. And then it wants to go up 2. So now if I go up 2, that means I'm messing with y. You can think of this as your old y's. It's your old outputs. So I'm just going to take this entire thing, and I'm going to move up 2. It's going to be plus 2. All right. That's 66. And now we have 70. So if I look at 70, it says describe and then sketch a graph. So for 70, it says g of x is equal to 5 of x plus 3 squared minus 2. First thing you have to do is identify the parent function. I think in this case, it's pretty obvious that it is x squared. So the first thing that happened, if we work from the inside out, so you always think about, if I evaluated this function at, let's say, 7, I would do 7 plus 3 to get 10. I'd square it, I'd multiply by 5, and then at the very end, I'd subtract 2. So that order, that PEMDAS order, is the order in which we would change this function. So first I go from x squared to x plus 3 squared, and that would move it left 3, because it does the opposite when I mess with x. And then it's all of these are my old outputs, or my old y values. So if I take all of my old y values and multiply them by 5, I get 5x plus 3 squared. That's going to be a vertical stretch by a factor of, 5. And then if I take that thing and turn it into this minus 2, then that is going to move us down 2, because I'm taking all my old outputs, all my old y's, and subtracting 2. Okay. So what do I need? All right, so it says that, and then it says sketch a graph. So sketch a graph of the transformation. So what I would do is, let's just do every one in turn. So I'm going to start off with x squared. And on it, it's going to have the point 0, 0, and 1, 1. So that now, so that is x squared. And now when I move it left 3, I can put it over here. So it's going to be the same shape. And now this is going to be 3, 0. It's going to be 4, 1, because I just changed the x's. I moved it left. Oh, sorry, I don't know which way my left is. Moved it left. So let's actually go left. Sorry, it's over here. Left. And so this is going to be negative 3, 0. And this one right here is going to be what? Negative 2, 1. But then I move it down. Oh, then I scale it by a factor of 5. So if I scale it by a factor of 5, it's going to multiply all the y's by 5, so it's going to be a vertical stretch. Well, the 0 stays in the same place, but this is now -2, 5, because I multiply all the outputs by 5. So again, the black graph is x plus 3 squared, and the blue graph is 5x plus 3 squared. And at the very end, if I move that thing down, it's going to look like this. And it's going to move down 2. This would be -3, 2. And this dot right here would be -2, 3. So I guess I need to take this thing. Yes, not drawn to scale. So I guess I need to take this thing and resize. I actually need to stretch it a little bit. Close enough. Horseshoes and grenades. No, let me do it again. So it's going to be that same vertical stretch like this. But I need to grab it. And if I move it down 2, it should be this picture, but just move down 2. So it's going to look something like that. Okay. And again, it's really hard to see because we have so many different movements. But this dot right here is -2, 3. And this dot right here, this orange dot, is -3, -2. Great work. That's 70. Let's go to 72. 72. If I've got k of x is equal to -3 square root of x minus 1, well, notice what was done. The -3 does a vertical stretch and a reflection at the exact same time. Reflect across the x-axis. Why? Because it's taking all the old y values. Because I noticed that my parent function in this case is the square root of x. So if I take that, and those are my outputs or my y's, really what you have here is -3 times your y's, and then you subtract 1 from all your y's. So first, I'm going to take this, and then I'm going to do this, which gives us that vertical stretch and reflection across the axis. And I go from here to here to -3 square root of x minus 1, and that moves us down 1. So here would be, all right, square root of x, and then if I both reflect it and pull it down, stretch it a factor of 3, then instead of 1, 1 and 0, 0, I now have 0, 0 and 1, -3. But then I just take this picture, and here's how I'm going to do it. I'm going to just take this picture. I'm going to copy it, paste it, and I'm just going to move it down, what, 1 unit to there. So now this is going to be the point 1, -4. So there's square root of x. Here is square root of x. Here is square root of x minus 3. And here is square root of x minus 3 minus 1. All right, that's 72. Now I need 77 and 78. 77 is a of x is equal to the square root of -x plus 4. So again, what is your parent function? My parent is this. I change it to this, which is reflect across the y-axis this time, because you're replacing all your x's with negative x's. So that's why it's a reflection across the y, right? So we go from here to here, and then we finally change it to, oh, that's interesting. Oh, that's interesting. We want to be really careful. So before I do anything, I'm going to get it in the right form. So let me go back. So notice how it's not in the right form yet. The form that we want is a f of b x minus h plus k. So that on the inside you have b parentheses x minus h. So in here, I think it's pretty clear that I have a negative and I'm adding, so I would need to factor out that -1, and I would get x minus 4. Okay? So now let's go in this order, and this is going to be correct. So notice we didn't put it in the right form. We know that a lot of math and science is about form. So the first thing I'm going to do is, from the inside out, is I'm going to move it right 4, and that would give me this thing. And then I'm going to reflect across the y-axis, and that's going to give me negative x plus 4. Okay, so I'm going to move it right 4, which gives me this 1, 2, 3, 4. So it would be this function. If your original square root looks like this, then square root of x minus 4 would look like this. And then we just reflect it across the axis. So it's going to go back this way. And that's what our function, negative x minus 4, is going to look like. Yeah. Cool. So, yeah, I need just one more second. If you can let people know, if you want to stand outside and let people know, just to be quiet as they come in, that'd be great. Almost done. So 78. 78 is this. So here's 78. It wants me to make this picture crop, but it wants me to, done. It wants me to find, if this is f, so if this is f of x, it wants me to find g of x, which is this thing minus 2. So we just take this whole picture and subtract 2 from the outputs. So I have a dot here. Instead of at 5, I'm at 3. So it should be nice and smooth up to here. Instead of here at 5, these are negative numbers. It's going to be down here at -7, so it goes like this, right? And it should go up like this. So just all the y values we subtracted 2. This, 1, 2, close enough? Yep. Okay, and then the last one is 80. We want to do f of x minus 2. So that means we shift the whole thing to the right 2 units. So for this one, I'm going to do that same paste. Crap. Same thing. Really? So let's just do it on here. I'm going to go right 2 units. So this one's going to go right 2 units here. So this one is going to go right 2 units that way. So that means it's going to be here. It's going to go up like this. And this one is going to go 2 units over. So it's going to be here. So it looks like it's going to be like that. This one is going to go 2 units over this way. So it's going to look like that. And this one is going to go 2 units over, so it's going to be over here. It's going to go down like that. It's going to come up. So if your function, the first one that I did was 78, and if this one is 80, so I did x minus 2. I actually did 81. So that's 81 that I did. I did g of x is equal to f of x minus 2, right? So this would move 2 to the right for extra practice. But then if you did 80 and it says g of f of x plus 1, you know that that's going to move 1 to the left. 1 to the left. So that means that this is going to be here. This is going to be here. It's going to come down like that. It's going to go up like that. It's going to come up like that. It's going to go down like that. It's going to come up like that. That's it. Have a good one.